Hey everybody, it's been a while since I made an update on what's going on with my engine, so I thought I'd go ahead and show you some things now that I've got some cool things to show off. I've been working on a server browser and server manager, and this is the server browser. What you can see right here is it says failed to connect to the server manager. That's because I need to run the server for the server manager. And then when I refresh here, there was a successful refresh, but there's no servers currently running. I can run these two different demos right here. And now when I refresh, I see two demos. So let's check these out. Let's say I connect to the basic physics character server, and it drops me in here. And then I can connect on a second client. And on the first client, I saw in chat when that second client connected. And it's nothing too spectacular here with the character demo. It's pretty basic. A couple of things that I put in to help with testing is I made the option to be able to modify the tick rate whenever I want, as well as the option to simulate latency. When you work with anything networking, you can be testing it on your local computer where you have zero latency and everything seems fine. But then once you add in some latency into the mix, everything just kind of goes to crap. First, let's take a look at the tick rate. So the tick rate is how many times a second updates will be sent for things like movement or whatever. And I have it defaulting to 16 right now, which is pretty low. Usually games have 64 tick rate, like Counter-Strike, things like that. And you can see 64 tick rate. Generally, this looks pretty good. Let's say that we had a tick rate of 1, just to get an idea. Well, we're only doing one update a second. And since we're sending the position and the velocity, you can see it kind of starts to look a bit strange. And just for one more example, here's a tick rate of 4, which also looks pretty bad. We'll go back to tick rate 16. Let's take a look at what happens when you have added latency. What I've done here is I've set my latency to 500 milliseconds, and it puts an additional latency of 250 milliseconds on everything outgoing and everything incoming. So if I start to move, I'll move half a second later on the other client. Let's try a much higher latency, like 1000 milliseconds, which would be 500 in and 500 out. One of the problems with something like this is, let's say this user is a bit up here, and this user is running, and they're going to run together somewhere. So they start running, and on this screen, on the left side, you see it looks like we're right next to each other. But on the right side, we're in completely different positions. And the reason that that's happening is because everything on this right side going in and coming out is delayed by a whole half second. What I did was I put in the option to approximate positions. And the way it works is extremely simple. So all I'm doing is when I get my updates, if I have if simulated latency, but really I could just put whatever your ping is here divided by 2 and use that value. But since I'm on my local computer, my ping's 0, so I can't use that. If I have the enable simulation approximation, then anytime I get a movement update, I'll just take my position and I'll offset it by the linear velocity adjusted for the amount of time based on the ping. Let's see what that looks like. We'll go right back into here, and now with it enabled, we'll connect on both of these, and I will set my latency back to 1000. Move this guy up here, move this guy back here, and start running. And now you can see it's never going to be great when you have somebody lagging that much, but you can actually tell a better idea of where their positions are. There's one thing about this that I haven't really figured out how I want to handle, and that's if somebody barely moves, because keep in mind, we're adjusting their position based off of the latency as well as their linear velocity. But if somebody just taps to move, you see they're really going. And I don't know a good way to handle that. And, of course, the reason that's happening is because once they start moving, I want that position to be accurate, or as accurate as it can be. But, of course, if they just tap a movement where I'm using the ping as a type of delta time, it doesn't look good. Then again, this might just be inevitable when you have such high latency. This was testing with 1,000 milliseconds, 500 in, 500 out. Maybe I shouldn't really be too concerned with this type of situation. Next, let's take a look at the vehicle demo. I've got my vehicles, and they work fine. That's all good. Of course, I'm using Jolt physics for all of the physics. And all I really have to do is I'm sending over all of my inputs when I do an update, as well as I'm sending over the position and the linear velocity that's currently going on. Now let's see what happens once we introduce some latency. For this, I'm actually going to use 1,000 latency like I did with the character demo. There's kind of a big issue here without any prediction. If this car is just driving, and then this car goes and hits it, right? On my screen, I was hitting it, but on this screen, I'm not. So I'm going to have this car rolling forward, and this car is going to go and drive into that car. But where there's latency, you see on the left side, I hit the car, but on the right side, I didn't hit the car. The prediction actually seems to work pretty well, but the downside is things just won't look as fluid. Let me go ahead and enable the prediction and see what that same scenario looks like. I'm going to be using 1,000 millisecond latency again. So 500 in, 500 out, and I'm going to just try to hit the side of the car. And as you can see, I'm actually able to hit it. That's all I've really got for this update. I appreciate you all checking out this video. I have been doing a lot of really boring, tedious things regarding cleanup in my engine. And now that I've got that out of the way, I'm hoping I can get on to some more interesting things and hopefully get some updates out a lot quicker.